Hello and welcome to A-Level PE 20 mark question Synoptic Screencast. So what we're going to have a look at then for the upcoming physiology exam, we're going to have a little look at the last question you're going to receive. Now, this is the only area, physiological factors, where you have a 20 mark question. You have a Synoptic 10 mark question in psychology and sociocultural. So you can see by the amount of marks that's available for this Synoptic link question, it's really important you understand, one, the process behind how you execute the answer, and two, have an idea of where these questions or these kind of topics are coming from. So if you have a look at these kind of the areas then, so what's going to happen with regard to your kind of Synoptic question is that you will have a question has to be split between one out of these three parts. Okay, so for example, part one might be from here. Okay, part two might be from here. Part one might be from here. Part two might be from here. Now, what I'm going to do over the next series of screencasts is have a look at how particularly part one can link to part two. Okay, so we're going to have a look at some specific examples of that. So just to have a look, the key focus for our first screencast is we're going to have a look at how the cardiovascular system in part one could actually link to three topics from within exercise physiology here. So that's what we'll have a look at now. So if we start off then, let's have a look at this. So if I just give you this could be a scene setter, you could have a graph. So this case shows the changes in heart rate of an athlete during a sub-maximal exercise session. Ignore the neural bit there, but if this came up and said, right, this is a heart rate graph, from there it could ask a variety of things. And, you know, it's basically saying, I think that the scene setter is important here, during a sub-maximal exercise session. So you can see there's a plateau. But the question, after you've got the graph, will start to ask you, sort of tell you where it wants to go. So if we started off here, I've looked at this as a part one. And I think this covers most bases from the cardiovascular system. It could ask you one of these or all three together, and we'll focus on all three together. It could explain how the neural, hormonal, and intrinsic mechanisms that cause heart rate to change during the submaximal training run. So you've got to use your knowledge on neural, hormonal, and intrinsic mechanisms and how they cause heart rate to change and the effect they have on an aerobic performer. I think they probably have a look at something along those lines. That's part one. Now that comes from the cardiovascular system, as I showed you before. Now on top of that, there's three second parts that you could get. Okay, so there could be more than that, but I'm just going to give you three examples. First one, okay, could be linked to explain the aerobic adaptations that will occur after a prolonged period of submaximal aerobic training like this, like a 12-week period, 8-week period, somewhere around there. Second thing it could be, if somebody is doing a submaximal aerobic training session, evaluate the use of ergogenic aids that could improve performance for the aerobic athlete or the submaximal training athlete. Finally, over a 6-month or devise a 6-month training program to improve aerobic capacity for the aerobic runner or the kind of middle distance runner or whatever they put in the scenario, taking into account periodization and principles of training. Now you don't actually get principles of training directly referenced in your specification, but knowing about them just allows you to kind of structure this part of the answer. So they're the three potentials. I'm going to go through those and we'll spend a little bit of time on each one. So we'll start off with part one then. Okay, so let's have a look at how you would structure part one. And remember, a synoptic question asks you to link. And this makes sense, doesn't it? If you're going to run like this continuously, you're going to need these three things in order to get your heart rate up, and then your heart rate will lead to stroke volume, cardiac output, etc. And then things that link to this are as follows, and these are aerobic links. So let's have a look then. First one, let's have a look then. So neural mechanisms, hopefully we're all okay with that. So when we see neural, remember we think of receptors. This is to do with heart rate. So we know it goes into the cardiac control center. You must say what the receptors are, what they detect. 3 receptors. If you want to add thermoreceptors in, you can detect an increase in temperature. That's absolutely fine if you just want to make sure you've got extra terminology. This information is sent to the cardiac control center, activates the sympathetic nervous system, stimulates the accelerator nerve, which stimulates the SA node to increase heart rate. Really important here that whenever you say that heart rate increases, you must then link it to stroke volume. Stroke volume will also increase. These two together, heart rate plus stroke volume, or times stroke volume, equals an increase in cardiac output. This is vital for the submaximal exercise, because it gets more oxygen to the working muscles. And you'll start to see that this happens with all of them. I haven't put it on here. I was going to write it on, but I can't today. My pen's not working. So I'll just say to you here, there, just make sure you've got that section at the end of this. A net effect of all of these changes are that an increased stroke heart rate will also increase stroke volume and cardiac output. Hormonal then. So when you talk about hormonal control, you're thinking about adrenaline. Adrenaline secreted from the adrenal gland stimulates the sympathetic nervous system, stimulates an SA node, leads to an increase in heart rate, which increases stroke volume, which then leads to an increase in cardiac output. Finally then, the third regulation mechanism is intrinsic control. Okay, so for intrinsic control, remember there's two key components, but one that gives us the kind of ability to demonstrate our technical knowledge, which is venous return plus temperature. So intrinsic control then, so during exercise, increase in venous return, increase blood to the right atrium, atrial wall stretch, increase firing rate of the SA node. That's your heart rate point. That's what causes heart rate to increase during that. But of course, it doesn't stop there with intrinsic control, because the heart rate and the firing rate of the SA node causes an increase in the blood forced down into the ventricles, which causes that ventricular stretch and contractility, and then that will increase stroke volume. Now, stroke, that concept of increased venous return, increase in stroke volume is known as Starling's law, and then on top of that, you've got an increase in cardiac output, which means that more oxygenated blood goes to the working muscles of the aerobic training run, or the runner, or the middle distance runner. Okay, so also there's an increase in temperature, increases the nerve transmission speed to the SA node. So that's that. That's part one. Now we'll have a look at the part two. So you've talked about an aerobic training run, a submaximal exercise session. Now we need to think from other areas of specification, what could enhance that? So first one then, okay, so explain if the performer had a prolonged, let's say 8 to 12 weeks training on this, what would happen? Okay, to the aerobic performance. Okay, so what would the adaptations be if they did an 8 to 12 week program on this? So I've gone through this loads. Hopefully you feel okay with this. You use the memory hooks here. 1, 2, 3, 4, 5, 6, 6, 8, 9, 10. Don't forget 8. 8 equals weight, buff, buffering capacity, increased ability to buffer lactic acid when taking part in aerobic activity. Can you make sure you add that one in? So you've done these memory hooks lots and lots and lots. From there, just add in number 8, weight. If you do weights, you get buffering capacity, increased buffering capacity, utilising lactic acid during aerobic exercise. So that's that. Do not forget that the net effect of all of this is an increased VO2 max and a delayed point of obla, okay, which means you can work for longer. So just as a pointer, I suppose, you've done loads of work on these, really revise them and make sure you're getting, good detail at the end of these. I'll give you the Synoptic link sheet. If you've done that, great. If not, just make sure you're practicing doing these. Aerobic adaptations are the only adaptations, flexibility and aerobic adaptation have not come up yet. Strength has. So let's just make sure you know this, because if it does come up as a 10-mark or 20-mark question Synoptic link, you should have a really good opportunity to showcase your knowledge and apply it. Okay, so going on then. Part 2. Second part 2. So we're looking here. Evaluate the use of ergogenic aids a performer could use to improve aerobic performance. So what we have to know then here is the fact that certain ergogenic aids are going to be really, really, really effective to improve aerobic submaximal training. So what I've done, I've kind of structured them hierarchically. So the top one here, we've got a pharmacological here. So pharmacological, remember, is done based around a pharmacy. Okay, so they're made in a pharmacy. They're pharmacological, an EPO. Now, EPO, remember, is that natural hormone we produce in our body. What we have to just make sure we're aware of the fact that, that's that, but recombinant EPO is what makes it pharmacological, because it's a recombinant, or it's a reformed EPO which we inject. And of course, once you know this bit that you inject it, okay, that then gives us advantages that are linked down to here and down to here, because these three both give us the advantage of red blood cell production. If you have an increase in red blood cell production, you have an increased oxygen carrying capability, which means you have more oxygen into your working muscles, which you can delay obla, you can work for longer, higher intensity, longer duration, all those things linked to these. What you have to know is the difference in the descriptions between them. So making sure you can have a good go at, say, blood doping. Okay, so take blood out. Okay, your own blood grows back, but then you re-inject your blood after cooling it back into your kind of bloodstream, which increases red blood cell. But that's a difference, because you're talking about the process that's different. benefits exactly the same. Okay, so when we talk about these, remember we're talking about the disadvantages lead to an increased viscosity of blood, increased chance of kind of therefore strokes, etc., blood clots and things like that. So make sure we just got that section there. Intermittent hypoxic training, that process of intermittent interval training, intervals in hypoxic altitude conditions, for example with an altitude mask, hyperbaric chamber, and then apart from down from that, of course, is then you also have periods of work when you're not in hypoxic conditions, you're at sea level. So I'll put you over a little bit in there in a second. Of course, the advantage of this stimulates EPO, which then stimulates red blood cell production with all the benefits that we talked about here. So these are the nutritional, these two are physiological. Okay, so they're physiological, and these are nutritional. So if I just got you to make sure you have a bit of information on these. Now, whenever you're talking about any of these, I'll put this one down at the bottom, because I mean, if it's in hot conditions, yeah, cooling aids can really help. But of course, the issue with this one is that, often it's used as a recovery. So is it going to improve the actual aerobic performance? Maybe not. So that's why I've left this at the bottom here. Now, whenever you're talking about ergogenic aids, and I've tried to use this example before, just remember, you go through a process. This question is saying evaluate the ergogenic aids and performance used to improve aerobic performance. So you've got to make sure, if you think about ergogenic aids, who's going to take them? Lads are going to take them. All the lads. Lads are going to take ergogenic aids. But we are doing an exam, so we're not talking about lads. We're going to de-lad every ergogenic aid, because you must make sure when you see an ergogenic aid, keep this process in mind. You've got to describe it. You've got to legal or illegal it. You've got to say whether it's an aerobic or an anaerobic ergogenic aid. In this case, the question's done it for us because it says it there. And finally, we've got to talk about advantages and disadvantages. Remember, all these. Red blood cell production, what does that mean? And if the red blood cells are increasing, of course, the blood viscosity is increasing because it's getting thicker, which is reluctance to flow. So you just got to make sure you get that concept in. Disadvantages, like I said there. So make sure you follow this DLAD process in a 20-mark synoptic question, because you've got lots of opportunity to show good knowledge here. Make sure you're linking it back to that aerobic performance. So the final one then. Oh, sorry, I'll put this on there. You can pause this. So I'll put these off mark schemes, recent mark schemes as possible I can find with regard to those ergogenic aids I've just mentioned. So if you want to have a look at this and just make sure you're okay. Obviously, I have set up an ergogenic aid screencast. The only thing that's not on here is nitrates, which I'll put on an ergogenic screencast a little bit. Yeah, I'll do a little short revision version of ergogenic aids just before the exam. Okay, going on then. The final part 2 we're looking at was going to link to devise a 6-month training program to improve aerobic performance, taking into account periodization and principles of training. So, periodization. If you're going to periodize training, if you're going to try and improve anything, you've got to do an initial assessment. So you're looking... Well, we're particularly concerned with your fitness testing here. So multi-stage fitness, gas analysis, just keep to the ones we've used. This is an old specification mark scheme. Then how we're using periodization. Well, if it's 6 months, we've got a macro cycle for 6 months, explain what it is, give some link to aerobic marathon running training. Do you remember what we did before when practicing for this? Then you go down to your mesocycle, microcycle, talk about how you could split your mesocycles into preparation, competition and transition, okay, and then make sure you've got this bit about tapering, okay, really reduced activity and recovery periods, training rate reduced and recovery periods reduced, and just make sure that allows you to resynthesize your glycogen stores. So that's the periodization section. On top of that, you're looking here, looking for particularly principles of training and how they would link to. Remember, the key principle of training we've looked at is fit. Okay, so we've looked at 2 to 3 times a week, 60 to 8% of your max heart rate, 20 minutes plus. Now, I think what we've got to do here, again, this is an old specification. If you can get these in, if it does talk about it, maybe just have a quick revision of them, of these principles of training, but make sure we are talking about HIIT training for our specifications, so make sure you know the differences for HIIT training with regard to ours, continuous, or we've looked at continuous. Make sure you know how to describe it. How do you describe interval training? I'm just giving you a structure for this from an old specification. Do not take this as gospel. Okay, so it's there, but you need to make it specific to our specification. So there are your 3 areas then. Hopefully people feel like they could have a good go at that. I'll go through your next bit now, which are respiratory system. We'll also have a look at energy systems. We'll also have a look at energy continuum. We'll also have a look at recovery, okay, and how they link to other areas of the spec. Okay, so please practice these, getting them into an order. If there's anything new here that you didn't think you had to revise, make sure you just add this into your revision process over the weekend. Okay, thank you.